So in the next example, let's solve part A. X minus 2 divided by x plus 5 is less than or equal to 0. So it's the same process. We find our critical values by setting the equation equal to 0. And there's one more little detail that I'll tell you about in a second. And then we use test values. Once we have our critical values, we use test values to determine which intervals of solution, which intervals are actually intervals of solution. So let's find our critical values. So the only difference here, so think about this guy. Think about this guy. To find the critical values, yeah, you set it equal to 0, just like before. But when is a fraction equal to 0? So you have x minus 2 over x plus 5 equals 0. When is a fraction ever equal to 0? Does the denominator have anything to do with it? Absolutely nothing. It's the numerator that tells you when a fraction is equal to 0. Think about it. 0 divided by any number other than 0 is 0. But if you try to divide by 0, that doesn't work, right? So when you set a fraction equal to 0, you can just drop the denominator and set the numerator equal to 0. Solving this equation solves this equation. Okay? Oh, well, that's actually pretty easy, isn't it? X equals 2. That was an attempt at a southern accent, a poor attempt. X equals 2. But wait, there's more. No, I got to say that in a more exciting voice. But wait, there's more. There's another critical value here. Okay, that fraction can change sign across 0, but it can also change sign across where it's not defined. So there's another critical value that you can get not just by setting it equal to 0, not just by setting the numerator equal to 0, but by setting the denominator equal to 0. That's now we're not that when we set the denominator equal to 0 and get x equals -5, that's not saying the fraction equals 0 there. No, it's undefined there. But the value of the sign can change across a value of x where the rational expression is undefined. So your critical values, that's the main difference here. So you get the critical values, CVs, by setting both the numerator, NUM, equal to 0, and the denominator, DEN, equal to 0. But that's the only change. Then you use test values to do the rest. So long story short, long explanation for a simple idea. Set x plus 5 equal to 0, get x equals -5, and these guys are your critical values. Oh, now it's exactly the same as before. So what we're going to do is all of this is step 1. Step 2, we're going to create that number line. We're going to put our critical values on that number line. -5 and 2. And then, kind of realize that there's separation created by those critical values. There's possible intervals of solution created by those critical values from -infinity to -5, -5 to 2, and 2 to infinity. The next step, step 3, let's pick some test values. What would be a good test value in the interval from -infinity to -5? -4.8 million? Okay, yeah, -6. Gosh, you're boring. Okay. So what happens if you plug -6 into this inequality? So you have a test value of -6. Let's plug it into the original inequality. That's a good one to plug it into. You get -6 minus 2 over -6 plus 5. Does everybody see what I did there? Just plugging in -6 for both x values. And then you have to answer the question, is that less than or equal to 0? Well, it's a negative. It doesn't turn out to be a negative divided by a negative? Yeah, which is a positive. So, I mean, you don't even need to know that it's -8 on top. All you really need to know is that it's a negative number on top. So I'm going to denote that by putting a negative in parentheses for the numerator. It is negative 8. If you want to write negative 8, that's fine as well. And then on the bottom, you get a negative 1. That's a negative as well. So really what it amounts to asking, I'm really asking you, is a negative divided by a negative less than 0? Is it? No. And we could be more emphatic. No. Don't be silly. So don't shade there. Does that make sense? That means no value from that entire interval from negative infinity to negative 5 will satisfy that inequality. It just won't happen. Okay, what would be a good test value from negative 5 to 2? Yeah, 0. And so once again, plug 0 into the original inequality for x. So everybody look where I'm pointing, up here. Plug 0 in there, so a test value of 0. And again, I don't care if you get the actual numbers. I just want the sign of the number in the numerator and the denominator. So what do you get when you do that? Negative 2/5. So you get a negative divided by a positive. Negative 2/5, right? Is that going to be less than or equal to 0? Question mark over the inequality. Yeah. Yes. So you're going to shade here. We'll talk about in other words, any x value from the interval between negative 5 and 2 will satisfy the inequality. Now we'll talk about what happens at the endpoints in a minute. But let's do our third test value from 2 to infinity. What do you want to pick? 3. And then, so a test value, see if I can fit it in here, a test value of 3. And then, do you see that it's going to be a positive over a positive if we plug a 3 in for x? You get 3 minus 2 on top, 3 plus 5 on the bottom. Positive divided by a positive, last time I looked, that was positive, right? So answering the question, is that less than or equal to 0, the answer is no. And so we don't shade in that interval. Does that make sense? Now, what's happening at the endpoints? Do we use brackets in the interval notation? Or, well, okay, be careful. On one of them, you use a bracket. On one of them, you wouldn't use a bracket. Even though it's a less than or equal to, there's one endpoint you wouldn't use a bracket on, that you wouldn't want to include. Think about what happens when you plug in. Is it bad to plug in 2? 2 minus 2 on top is okay, isn't it? Is it bad to plug in negative 5? Negative 5 plus 5 on the bottom is not going to work because you get 0 in the denominator. So does everybody see that even though it's less than or equal to, you're going to use parenthesis, you're going to use a round bracket, in other words, around the negative 5 to indicate it's not included, because if you plug in negative 5 for x, you get division by 0. 2 is fine. If you plug in 2 for x, you get 0 on top and 7 on the bottom. 0 divided by 7, that's fine. That's 0, which is less than or equal to 0, right? 0 is less than or equal to itself. The or equal to part is what's satisfied. So you use a bracket around that too. So I'm going to write that. I mean, the interval notation is right there for you. I'll clean it up in a second, but does that make sense to you? Yeah.
So we're seeing that because it would be undefined if it was something divided by 0?
Exactly. If you try to plug in negative 5 in that original inequality for x, you get division by 0, which isn't, it's nothing. It's not nothing, it's undefined. We usually think of nothing as 0. It's undefined. You can't divide by 0. So the negative 5 is not included. So our answer, if you remember interval notation, you just strip away the number line, keep the negative 5 and the 2, and then the symbolism, the parenthesis to indicate negative 5 is not included, and the bracket around the 2 to indicate that it is included.